Hello and welcome to this PIR live event brought to you by Partners in Research Canada. My name is Ben Hobbs and I will be your host today. For those classrooms who have joined us for live events previously, you'll notice that we have the chat disabled. That's because we're trying to direct you to Zoom's new Q&A feature. You can use that by clicking Q&A, which is located in the center bottom of your screen. If you see a question that you would also like answered, you can prioritize that question by using thumbs up, and I will relay these questions to our guests during the Q&A period of the webinar. So without further ado, today's guest is Dr. Lynda Colgan, Professor of Elementary Mathematics in the Faculty of Education at Queen's University. Thanks for joining, Dr. Colgan.
Thank you for having me. This is an exciting afternoon.
It's my pleasure. I'll let you take it from here.
Okay. I am going to share my screen here. So here we go. There we are. One of the things that I'd like to do over the next few minutes are some magic tricks. These are magic tricks that involve some arithmetic and some patterns. And one of the things that we'll talk about a little bit at the end of the webinar is how these magic tricks were created. And you can perhaps start thinking about how you can create some of your own magic tricks. So I like to think of this afternoon's little event as something called Math In and Magic Out. So here we go. One of the things we are going to do, I have a little agenda here for you. One of the things I am going to do is predict your secret number. That means that no matter who is in the audience, I am going to be able to tell through the magic of numbers what number you are thinking about. I am going to be able to predict the age of every single person in today's audience. I am also going to be able to pick your number from a set of cards. And at the very end of today's activities, I'm going to prove to you that I can see right through a stack of dice all the way here from Kingston, Ontario. So here we go. What I'd like you to do is have a piece of paper handy, a piece of scrap paper. I'd like you to have your pencil. And you are allowed to use a calculator if you wish, but I've tried to keep the numbers not too big, so if you don't have a calculator, it's not essential. You'll still be able to participate. Now, it's very important for this first step that you not show anybody around you what you're writing down. So just use your arms to shield what you're writing down, because that will help me to predict the answer. It will help the magic happen. I would like you to pick a number, your favorite number, between 1 and 8. And I would like you to write that number down, but don't let anybody else see it. A number between 1 and 8. Oh, I'm hearing a lot of thinking happening here. Okay, we're going to move on. I'd like you now to multiply that number by 3 and write down your answer. Okay. Now I would like you to add 3 and write down your answer. Next, I would like you to multiply by 3 again. I hope everyone's keeping up. The next step is that I predict that everybody in the audience today has a 2-digit number in front of them. Now, what do I want you to do with that 2-digit number? This is what I want you to do. I want you to add those 2 digits together. Have you got those 2 digits added? Now, on the count of 3, I want you to shout out that number. Are you shouting? I predict that everybody shouted out the number 9. Am I correct? Yay! That's Mathemagic. We got your secret number. It didn't matter whether your favorite number or your secret number was 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. No matter what number you started with, every single person in the audience ended up with 9. That's Mathemagic. Okay, we're going to do another problem now. And in the end, I'm going to know your secret number, and I'm also going to know how old you are. Are you ready to begin? Do you have your papers and pencils ready? All poised? This time you might need a calculator because the numbers are just a little bit bigger. So here we go. I'd like you to pick a number between 2 and 9 this time. And just like before, don't show your number to anybody. So a number between 2 and 9 that is your favorite. Now I'd like you to multiply by 2. So you're going to double your number. Now I would like you to add 5. Now I'd like you to multiply by 50. Multiply by 50. I can hear lots of work happening there. Now, this is very important, so pay attention to this step. If you have already had your birthday this year, I would like you to add 1,768. If you have not had your birthday this year, I would like you to add the number 1,767. Next, I would like you to subtract the 4-digit year that you were born. Okay. Everybody, I'm thinking very hard right now. If you follow those steps correctly, you should have a 3-digit number in front of you, either on your calculator or on your paper. The first number should be the secret number that you picked at the beginning, and the last two numbers should be your age. Did it work? That is Mathemagic. A 3-digit number. The first is your magic number, your secret number. The second 2 digits are your age. Okay. This one is going to require a bit of concentration. So, I am going to ask my handy dandy assistant here.
Hello.
Hello. To help me out a bit.
That sounds good to me.
I would like you to pick a number between 1 and 63.
Okay.
And I'd like you to write that number down.
I have the number.
Okay, I do not want you to show that number to me, but I want it to be written large enough so that everybody can see it in a minute, okay?
Okay.
I am going to ask you right now, is your secret number on card number 1?
It is.
Okay. Is your secret number on card number 2?
It is not.
Is your secret number on card number 3?
Yes, and Lynda, I apologize here. It looks like I've already made a mistake. My number is in card number 2, and it is in card number 3 as well.
Okay.
The first 3.
All right. Is your number on card number 4?
No, it is not.
Is your number on card number 5?
Yes.
Is your number on card number 6?
No.
I'm thinking very hard. I believe your number is 15. Am I right?
I am very impressed. My number is indeed 15, and I hope everyone can see that.
Okay.
15 right there.
All right. And we did not practice that trick ahead, did we?
That is true. We have not talked about this at all.
Okay, so this time, what I'm going to do is ask you to pick a secret number again.
Okay.
I want you to write it down on the piece of paper again.
Okay.
This time, I'm going to turn around so that I can't see.
Is the secret number between 1 and 63 again?
1 and 63.
Perfect.
So I'm going to turn around so I can't see, and I want you to show our audience what your number is, please.
This is my new number for everyone. Hopefully you can all see that. Okay, Lynda, I think everyone's seen it.
Can I turn around now?
You can turn around now.
Okay. Here we go. Is your secret number on card number 1?
It is on card number 1.
Is your secret number on card number 2?
Yes.
Is your secret number on card number 3?
No.
Is your secret number on card number 4?
No.
Is your secret number on card number 5?
No.
Is your secret number on card number 6?
Yes.
So, you told me that your secret number was on card number 1,
Mm-hmm.
card number 2,
Yes.
and card number 6.
Yes.
I predict from card number 1, card number 2, and card number 6 that your secret number is 42. Am I correct?
Correct.
Am I correct?
I'll show you are correct. And the
Okay. That
I confirm that is correct.
That is Mathemagic. That is Mathemagic. So just imagine, out of all those numbers, just by you answering a few little questions, I can predict your secret number. So here we go. On to the last one. And this is going to be spectacular. I am going to prove to you that I have X-ray vision. So, I am going to ask I'm going to ask one of the classes in our audience to make a tower with 2 dice. With 2 dice. And then what I would like you to do, using the Q&A, is send us a message that tells us what the number is on the top dice. What is the number on the top dice? So has someone written in with a number for us?
Yes, so we've got 1, 5. Are you looking for just one answer?
You know what? I'm going to go through all of them. So here we are. So the person the class that has 1 on the top of their stack, they will notice that there are 3 sides of the die that they can't see. There are 2 sides that face each other and one face that is on the bottom of their tower. I am going to predict that if they look at those sides that are invisible to them, I happen to know that those 3 sides will add up to 13. Would you ask them if that's correct, please?
Is that correct? Do they add up to 13? I think we have some people counting.
Did it add up
Correct.
to?
I have someone confirming that it does add up to 13.
There we go. And you told me that there was someone else who had 5 on top of their die.
Yes.
So if I use my magic powers and they've got 5 on the top, I believe that if they look at their 3 hidden faces, those will add up to, let me see, 9. Would you ask them if that is correct, please?
So classrooms with 5 on top, do they add up to 9? Can you confirm for us?
The hidden faces.
The hidden faces, do they add up to 9? Jocelyn Little's class can confirm for us. Yes, that is correct.
Aha. Does anyone have another one that they'd like to test me on?
What about number 6?
Oh, if the number 6 is on top, I am going to have to think about this for a minute. I predict that the 3 hidden faces will add up to 8. Am I correct?
Can someone check that for us? The 2 hidden faces, when 6 is on top, will add up to 8. 8 worked.
There we go.
Awesome.
So I'm going to make this 1 dice harder. I'm going to ask the classes to please build a tower with 3 die for me.
Wow.
With 3 die. This time, there should be 5 faces that are hidden from them if they just look at the tower, because they're stacked one on top of the other. I am going to predict the sum of those hidden faces, and all I need is 1 clue. What is the number on the top?
So can someone give us a number on the top? First one I see is 2.
Ah, I predict that the other 5 faces sum to 19. Could you please confirm that that is correct?
Can anyone with 2 as their top number confirm? Might take a bit longer to count them up this time.
Mm-hmm.
And we're looking for 19, is that correct?
Yes, we are.
Yes, it looks like they do.
Aha! I'll try one more. Give me a number on top.
Let's go with Greg Turner's class. Oh, shoot, Greg, I'm sorry I missed your... Greg Turner, number 3.
Oh, okay. Number 3 on top. I predict that the 5 hidden faces will sum to 18.
18, okay, sounds good.
Let's see if Mr. Turner's class agrees.
Yes.
There we go. And
awesome.
Wasn't that classroom all the way in Kelowna?
I think so.
Yes. So even from Kingston, Ontario, my X-ray vision works on those die. Pretty amazing all the way across the country. Okay, we're going to stop there, and I am going to ask if there are some questions, and I'll be happy to answer.
All right, that sounds good. So,
do I stop sharing my screen now?
I'll have you stop sharing your screen now.
Okay.
Okay, so does anyone have any questions? I'm sure we have.
I hope we had fun.
Yes, I'm sure everyone had fun. Well, our first question, I don't know if you're going to be able to answer this one. They would like to know how the last trick works.
Oh, you know what? I have to tell you that normally a magician never gives away the secrets to her tricks. But this is something that I'm more than happy to share so that you can go home and try it with your family this evening. There is a secret that everyone should know about a die. The opposite faces on a die always sum to 7. So if you have a 1 on the top, I'm just looking for my die. My big die has disappeared from my office. I think someone borrowed it. So if you have a 1 on the top, that means on the other face, on the bottom, you automatically know you have a 6. If you have a 2 on the top, you automatically have a 5 on the other side. If you have a 3 on the top, you have a 4 on the opposite face. So every time you look at a die, the opposite faces sum to 7. So I know that for one die, the top and the bottom add to 7. For 2 die, they will add to 14 because it's 2 times 7. For 3 die, it's 3 times 7. And 4 die, I could do a stack as high as I wanted. All I have to do, for example, for this stack of 2 die, if you tell me that the top is 2, I subtract 2 from 14, and I can tell you that those other faces will add to 12. And if it was the fact that you were giving me 3 die, the 3 die would add to 21. So if you told me that the top was 4, I would say, well, then that has to be 17 for those faces I can't see. So there you go. There's a trick that you can use with your friends and family and impress them about how you know some Mathemagic.
I'm impressed. So everyone can go home tonight and show their parents how smart they are and trick them. Mm-hmm. So our next question from Ms. Peters' class is, for the other trick, why does the first number have to be between 2 and 9 and not something else?
The reason, the very first trick, I asked you to use a number that was, I think, between 2 and 9, is because one of the things that is very special about the number 9 And I needed you to end up with a multiple of 9. So if you saw in that trick, I asked you to multiply by 3, to add 3, to multiply by 3 again. So I was actually asking you to multiply by 9. If you think about if you think about 9, 9 times 1 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. So if I think 2 times 9 is 18, oh, here's a magic thing. 1 plus 8 is equal to 9. So I know that 9 goes into 18. If I look at a number like 27, 2 plus 7 is equal to 9. So I know 9 goes into 27. If I look at 36, 3 plus 6 is equal to 9. So 9 goes into that number. So again, one of the things that's important, if I look at a number like, let me say 23, 2 plus 3 is equal to 25, and that is not divisible by 9. So I made the trick so that you would end up with a multiple of 9, and that's why everybody was able to yell out 9 at the same time. Okay?
And I think that sort of answers our next question. Margaret Coyle was wondering, could anyone do this if they learned how?
Absolutely, absolutely. Basically, what we're actually doing here is using basic algebra. And one of the things that we start when we use algebra, we use tiles and beans to represent. And we make up a whole series of little tasks for you to figure out. Now, I have a book, and I'm sure it's in your school library, and I'm sure it's in the public library near you, and it's called Mathemagic Number Tricks. And if you borrow that book from the library at your school or at home, you will find the secrets behind all of the tricks that I did today. And then you will be a mathematician too.
Wow, well, that is good. I'll have to check out that book. Greg Turner's class from Fort Francis. How did you do the age trick?
The age trick is a funny trick, and it is, again, based on just some very simple algebra, and it's based on the fact that we are in the year 2018. So I use different multiplication and addition facts to actually end up with the year 2018 in there, a multiple of 2018, so that when you subtracted the numbers that I gave you, which were 1,768 or 1,767, what I knew was you were going to end up with your age. And again, just because of the way we organized the arithmetic, the single-digit secret number was part of that. So that one required a little bit more algebra, but I hope you enjoyed it. It was fun, wasn't it?
So our next question, coming from Brady Wadersworth, how long have you been doing math for?
I've been doing math for a very, very long time. I have to tell you that when I was an elementary school student, which was a long time ago, I went to Bruce Public School in Toronto, and I had a wonderful teacher in grade 4, and her name was Mrs. Harvey. And Mrs. Harvey actually taught our class, if you can imagine, how to do some very simple number tricks. And I had so much fun with those. I would go home and try them out on my parents. And then I joined a math club at my school, and we did more of those. And then when I went to high school, and I had a wonderful teacher at Riverdale Collegiate, whose name was Mr. Saramaki, he taught us even more magic tricks. And I just made it my hobby to try to learn as many more as I possibly could. It's something I have a lot of fun with. And just hang on one second. I even have a magic hat now. because I love doing magic tricks. And I don't know if you can see on the side of my hat, it says, J'aime les maths on one side and I love math on the other. So I try to wear my magic hat whenever possible. So there you go.
Awesome. Okay, our next question. How did you find the numbers in the cards?
Oh, can I go back and share my slide on my screen on that for me? Okay, so this is a very interesting one. I'm going to go here and share, and I'm going to go back here. There. So this is an interesting trick. This is actually based on the binary system, which is how computers work. And again, if you're really interested in all the details, in my book, Mathemagic, it's explained in great detail. But here's an example. Can I have you pick a number for me again?
Sure, 1 to 63 again?
Yeah, 1 to 63.
Okay, so I've got my number.
Okay, but I'd like you to tell me.
So this time my number is 10.
This time your number is 10. So if the number is 10, this is what I'm going to do. I am going to ask, is the number on card 1? If the number is on card 1, I make a special note of the fact that there is a number 2 in the corner. Now, because 10 is on that number, is on that card, right?
Mm-hmm.
Then I go through and I see that 10 is on card 2 as well.
Mm-hmm.
So I make a special note, again, number is in the top corner. I look at card 3, there's no number 10. I look at card 4, there's no number 10. I look at card 5 and I look at card 6 and there's no number 10. So that tells me that all I have to do is add the 2 and the 8 together and I'll get 10.
Ah.
So give me another number.
I'll give you 12.
12?
Mm-hmm.
Okay. So is 12 on card number 1?
I don't see it. I don't think so.
No. Is 12 on card number 2?
It is.
Is 12 on card number 3?
Yes.
Is it on 4?
No.
Is it on 5?
Nope.
Is it on 6?
Nope.
So all I have to do is concentrate on the fact that you told me it was on card 2 and card 3. The top number on card 2 is 8. The top number on card 3 is 4. 4 plus 8 is 12. So if we have a more complicated number, for example, I'm going to pick 41 as an example. 41. Is it on card number 1?
I don't think so. No.
Is it on card number 2?
Yes.
So I have to make special note of that. It's on card number 2. Is it on card number 3?
I don't. Am I missing it? I don't see it.
Okay. Is it on card number 4?
No.
Is it on card number 5?
No.
Is it on card number 6?
Yes.
Okay. So what do I have to do to get my number? What special numbers did I have to pay attention to?
I see 8.
Mm-hmm.
Mm-hmm. And we've got 32 on card number 6.
Okay.
And we have 4 somewhere on card number 3, was it?
Now, what number were we looking for?
44.
44. right?
Mm-hmm.
Is that right? We were looking for number 44.
That makes sense to me.
Okay, so I'm just asking you, I'm reminding myself because I've forgotten. So if it's 40, the number is 44, it's on card number 2. If it's number 44, it's on card number 3. If it's 44, it's on card number 6. So 32 plus 4 plus 8 gives me 12 plus 32, which is 44. So all of these various numbers will add up to the number that you need by just picking the number from 1 to 63. And that's because they're in what we call base 2.
Ah, okay.
Okay, a little more complicated, but still a lot of fun.
Mm-hmm. Well, thank you very much. We're running just a little over time now, so I'll ask you to maybe wrap up with some advice for students who are maybe considering going into math post-secondary but are a little unsure or don't know what to expect.
Well, one of the things that I'm just going to mention here is that mathematics, whether you are in grade 4, whether you're in grade 9, or whether you are in high school, is extremely important to keeping doors open. One of the things that I am going to surprise you with is a fact that in order to get into more than 75% of programs at college, universities, and apprenticeships, whether you want to be a plumber or an auto mechanic or an astronaut or a doctor or a chef or a veterinary technician or a hockey player, you still need to have math. And one way to make sure that you keep math on your path is to always find ways to be positive about it, always find ways to find it interesting, and most importantly, to remember that sometimes you have to try something more than once in order to be successful at it. For me to learn some of these tricks, I had to practice over and over and over again before I even would try them out on my family. And that helped me to become more confident and to love math even more than I did. So keep math on your path. Okay. Thank you.
Thank you. Thank you. That's all the time we have today. But again, thank you, Lynda, for showing us some of the math that we might not realize we're doing every single day.
Every single day.
Mm-hmm. So next week on Partners in Research Live event, we will be discussing male and female curiosities of the animal kingdom with Dr. Amanda Mooring from Western University. More information about these webinars and other PIR educational programs are available at pirweb.org. Thank you for tuning in and have a wonderful day.
Thank you.
Bye.